For this case study that we call ELRF, it's found here, ELRF. LR stands for link ratios. They give answers that are too high, and we'll explain why they do that and how do we know that. We're going to compare the Mack method and related methods to PTF-type models, and how do we kind of decide on assumptions going forward. Okay, so this is quite an interesting study. Let's open the triangle group, and you'll see that for the incremental triangles, the paid losses incremental, the case reserve estimates, and the number of claims closed, we have models. And for the paid losses, let's highlight M4 and M5, and we can run them simultaneously in 2 runs of PTF. So you click with the right button of your mouse, click on Open. If you now go to Tile vertically, minimize other types. So you'll just get the 2 model displays. Click with the right tile vertically. You'll see in one of them you have many calendar year trends, and the other ones you don't. If you look at the title of the display, it's this one on the right has PTF. The model is M4. It's run 1. The one on the left has PTF model M5, but the run is number 2. So we're running 2 different models in PTF. We've got 2 runs of PTF working at the same time. Now, if you open the logbook simultaneously, one way of doing that is with the right button of your mouse on the logbook icon, right mouse. Which one do you want to open? You want to open all. In this case, it's just both. Take the first logbook, push it down. You'll see that in each model we're using the same number of observations, capital N, but M4 has a much lower BIC, so we're going to sort of ignore M5. Now, to close the run 2, all you need to do is highlight it, either open the regression table, EOM, the regression table. I find it difficulty in pronouncing the letter R, R as in Robert. One way of closing that run is you just click on X. If we just review the calendar year trends, they are in fact decreasing. They are huge trends, but they are getting lower and lower. To close this module, the PTF module now, you can either click on the X, but if there were many of them, you had many runs and you all will close them simultaneously, you can either close all regression tables or close all PTF modules. Whoops, we're back into the database. I kind of thought it might get us back to the triangle group. The triangle group is probably still open, so you click with the right button of the triangle group tab. There it is, LR. It takes us back to there. Case reserve estimates, we'll assume we'll run with M4. Number of claims closed. Well, there's an M2 and an M5 is probably, let's run M5 for instance. We'll run both of them. Open. The one we're going to be spending more time on is going to be also M2 in this case. So I've decided that. Why did I decide that? Because I just remember that if you look at the logbooks, each one uses 155 observations, but you'll see that the AIC, the BIC is less. It's 84.5 versus 91.7, so M2 is better. So let's close all regression tables again. So X with the downward arrow. So the ones we'll focus on, the triangle group disappeared. Now, if it has, you can either click on this button, triangle group view, the one that has lots of triangles here, under the triangle group tab, the one on the extreme left, or you click on the triangle group tab there with the right button, select LR. You've got a choice of 2, but let's click here. Okay. All right, let's go to paid losses cumulative and click on ELRF, and we'll look at the residuals. And now we find that the Mack method overfits or has a trend in it which is much larger than the trend in the data. So this is trend in data minus trend in method, and that's negative. So I don't know what trend the Mack method's actually estimated to the data. There are no descriptors of it. If you go to the regression table, regression, R is in Robert, regression table here, ERM, there's no descriptors of the trend, but all I know is the difference between the two, which is negative. If we do a forecast dialog box, go to the logbook, LOG, scroll to the right. Well, actually, you don't have to scroll to the right, so I was ahead of myself. 186 million, plus minus T stands for thousands, 104. Go to model templates, and select delta equals 2, which is the arithmetic average. Okay. Of course, the residuals are still pretty bad. Forecast. Look at all the overfitting you're doing here in the most recent. And also you've got skewness of the observations. You probably don't have normality, just for fun. No. Forecast dialog box. I'll close the normality display. Forecast dialog, yellow arrow, logbook. And now the answer is over 1 billion. Now let's go back to model templates. Go to trend and ratio, select delta equal to 1, OK. Go to residuals, green diamonds, and assign 0 weight to the early calendar years, all the way to about, say, I'll wait for you, till about 84. Let's see what happens when you do that. Estimate. Optimize twice. So you'll see that this model hardly ever uses ratios. So if you go back to the regression table R, most of the ratios are set to 1. Minimize it, don't close it. Let's save this model. Let's call it good 1. It's not really good because you don't know what's going on in the data, and you don't know what the trend in the data is. But the trend in the method versus the trend in the data, well, they seem to be about the same because the difference in the two trends is about 0. Do a forecast now. Go to the logbook. And the answer, I guess, is a little bit more than half. Well, that's a big difference, isn't it? That's a very big difference. So, you know, the Mack method can really overestimate the reserves that you should hold. There are also cases which can also underestimate it. Let's go back and refit or re-estimate the Mack method, ratio only, delta equal to 1, and close the logbook, close anything, well, except for the regression table if you see it. Okay, just minimize the residual graph. Same. Now, if you're back inside the triangle group, well, we can minimize that also. Let's go back to the database. Well, actually, you could go back to the database without. One way to going back to the database, if you're already on the database tab and you can't see the database, is you click on this button, Open Main Database View. If you can already view your database, I guess you don't have to click on this button. Go to a triangle group called SDF. That's further down. Open that, and you can double click on it. That's another way of opening it. Go to Triangles tab. The paid losses are highlighted. We're going to simulate a triangle. So go to S. There's a button under the Triangle Group tab, extreme right. There's a Simulate Triangle tab, button, icon. Click on that. Let's set alpha equal to 10. Now we're going to do a simulation, so we're not going to get the same simulated values, but each one of our triangles will have the same trend structure. Make the variance 0.1, so we're setting alpha to 10, constant inflation of 10%, gamma, the decay is minus 30%, of course the resulting trend will be minus 20, the variance is 0.1, and save data set here, bottom right, click, put a tick mark, save model parameters with data set. Okay? Now, click on OK. Let's save the parameters, true parameters. Save. Now go to the other data sets or models tab. Highlight the paid losses simulated. And then you haven't designed any models, but you have saved parameters. So if you go to the parameters button here on the right of the models, so you've got models, the non-models here, right? Click on parameters. True parameters, you save that. Double click on that. So these are the true parameters, minus 30, 10, alpha equals 10. Now if we look at the residuals, all you're really looking at is the random numbers that you generated from a normal distribution with mean 0 and variance 0.1 in the 3 directions. So our graphs are not going to be the same because we didn't simulate the same values. For instance, this observation here is obviously an outlier, but it came from a normal distribution. Now we want to really estimate the parameters in the data we simulated from the trend structure that we know. So you go to model templates. By default, it's the SGI, single gamma model with inflation, which is kind of the starting model when you get to PTF, unless you're loading a model, running a model. Click on OK. And look at the model display. Tile vertically. Minimize regression tables. So you've got the model display and the residual graph. If you look at the residuals versus calendar year and set the trend to 0, so you click on the little box on the x-axis, on the horizontal axis, above the number 79. The red line means set a 0 trend, but we need to estimate it. So now the method along the calendar years estimates a trend of 0. But you can see that versus calendar years, there is a positive trend, which I guess is around the 10%. So now if you do a forecast, it'll be way too low because the trend in the method is much lower than the trend in the data. In fact, if you look down your forecast table, your numbers won't be the same as mine, but you'll see fitted value much lower, mean value much lower than observed, much lower, okay? If you go to logbook LOG, scroll to the right, you'll see that you get somewhere around 787. You want not the same number as I, but it'll be close to it with a standard deviation of around 61. Now go to the residual graph, click on residual, model display, the one with the blue. Now set the trend, estimate the trend between 78 and 79, so you're adding a parameter. Click there between 78 and 79 on the vertical axis of the residuals versus calendar year. Then click on E to estimate. Now we're estimating a trend IM of 9.83 plus minus 0.7%. Yours will be around there also. Forecast. Okay. And now if you look at the logbook, LOG, it is much larger. It's more than doubled. Okay. Now, instead, in fact, your answers for mean reserve and standard deviation wouldn't be too far from the answer I actually get. Now we want to set the trend to 20%, which is much larger than the trend in the data. So now you go to this particular icon, this particular button. Obviously, it's under the PTF tab. It's the third one from the left. You've got model templates. Here you load a model. The next button, when you point to it, it says model parameters. This one here, the third one from the left, under the PTF tab, click on that. You've got 3 tabs within this particular window. Let's go to calendar year parameters. Set the initial iota to 0.2. That's the calendar year trend. If you make the initial variance 0, all you're really saying is that you're giving it full credibility. It's 20% plus minus a variance of 0. No uncertainty in it. So if you click on E to estimate, you're estimating a trend along the calendar years of 20%. But if you now look at the trend in the method, subtracted from the trend in the data, From 10%, we're subtracting 20%, so this must be minus 10. If you do a forecast now, forecast, okay, logbook, log, and you can see that it more than doubles again, and it's way too high. So, I mean, if you look at the forecast table, click on F for forecast table, you'll see that the fitted values are much higher than you observed. But you can see also that in the residual graph. Now close the forecast table if it's open, close the logbook if it's open, close the model display if it's open, go to ELRF with the right button of your mouse. It's the way to navigate. So we're going back to ELRF. It's open, LO high, paid losses cumulative. The current model is model good 1. Click on the residual graph. Well, actually, it's not. That's the last model that was saved. Now, this is the Mack method. Let's just check again. You go to model templates. You delta 1. Okay. Now let's tile vertically, minimize regression tables, and let's see what's going on here. On my left side, it's the Mack method applied to real data, cumulative paid losses. We know that the trend in the method is much larger than the trend in the data. On the right side, it's based on the simulation. The trend in the method is 20%. We know the trend in the data is 10%, and the difference is data trend minus method trend is minus 10%. Very important, very important, okay? Right side based on simulation, this is a Mack method. So sometimes the Mack method, if it overestimates the trend in the data, then the answer, everything else being the same, everything else being right, the answer will be way too big. If it understates the trend in the data, the answer might be too small. But I guess the other thing is that with the Mack method and ratios, you don't have any control on not just the trend estimated in the data, but also the trend estimated, used in forecasting. So to illustrate this last concept, why don't we close all triangle groups? So you go to X with the downward arrow, close all triangle groups. The model's been changed, you want to save? No. Let's go back to SDF. So open SDF. And now go to Triangles tab, click on PLI Sim, and we want to create its corresponding cumulative. You can click with the right button to transform, but you won't get a menu, and it'll just, let's do it, just for fun. Transform, you get PLC Sim. That's the cumulative. Delete it, right button of your mouse, delete it. Yes. Now, if you go back to PLI Sim, you can also go to this button, Transform Triangle. It's under the Triangle Group tab, Transform Triangle. You've got 2 triangles with 2 arrows. Click on that. You're going to create cumulative. It's going to be called PLC Sim. Okay, just another way of doing it. If you now go either to the Datasets tab, Models tab, doesn't matter, and click on ELRF, we're using the Mack method on the cumulative data, and we know how we simulated the data on an incremental scale. We know that on an incremental scale, there's a 10% calendar year trend. The volume trend is minus 30. Alpha is around 10. Volatility on a log scale is about the variance of the normal distribution is 0.1. Let's click on the ELRF. Go to the residuals. Now, you won't get the same residuals as me, but doesn't matter. But if you look at residuals versus calendar year, apart from the skewness, let's discuss the skewness first. Click on normalities, the diagnostic tools. Do we have normal distributions? The answer is no. Why not? Let's close the diagnostic tools. We simulated numbers on the log scale with a variance of 0.1. It's not such a big variance. it means on the dollar scale, the log normals are quite skewed. And you can see that when you look at the residual graph of the Mack method. But the Mack method has essentially captured that average calendar year trend of 10%, by and large. Not a great job, not in my particular simulation. Yours might be a bit better. But I don't have any description of that trend. I don't know about it. If I look at the regression table here, ERMO as in Robert, it doesn't tell me what the trend is. And if I do a forecast, implicitly, I'm forecasting with a 10%, but I don't know that it's 10%. I have no idea that it's 10%. Whereas on the other side, in the PTF modeling framework, not only do you know what trends you've estimated in the data, but you also have control on trends going forward. How nice is that? Okay, let's close the ELRF module. Close all the ELRF modules. Oh, we're still in the triangle group SCF. I guess we want to close that also, so close all triangle groups. Let's now go back to LR high. And what we want to do really is run a model for the paid losses, case reserve estimates, and number of claims closed. So click anywhere on this left side window pane on the right. So you've got all the model listed for each type of triangle. For the paid losses, we're going to get M4. For the case reserve estimates, M4. And for the number of claims closed, select M2 with your control key and your mouse. Now click with the right button of your mouse and open all. Now tile vertically, minimize other types. Just go tile vertically again. And let's look at what goes on along the accident years. You'll notice that the case reserve estimates and the paid losses have got this kind of ball-shaped. Actually, it's a bit skewed. It goes down. It's a bit of a well, I guess it doesn't really look like a cereal bowl. So that it goes down. It seems like some kind of correlations in the way the trends work. It picks up between 88 and 89. Over here it's really 87 and 88. Whereas the number of claims closed, well, not exactly the same shade. What about versus calendar years? Let's study the paid losses first. The paid losses seem to have calendar year trends that by and large are decreasing. The 8% plus minus 0.97% is probably it's the lowest trend that's been since 1974 to 91. The case reserve estimates are also increasing, huge trends in the early years, but more recently the trend is zero. So the guys calculating the case estimates are not increasing their trend. There's no trend at all. They're not increasing. There's no inflation in the case estimates since 1987, but there is inflation in the paid losses. The number of claims closed actually go down here more recently. So if you're closing, needs further investigation, if you're closing fewer claims, especially from 90 to 91, 88 to 89, but yet your case estimates are level, there's no trend in the case estimates. If you're closing fewer claims, you probably have more claims open. If you've got fewer claims open and the case estimates are not going up, I guess the guys calculating the case estimates probably have the view that this decreasing trend along the calendar years, the future calendar year, might actually be lower. Their view is not that this calendar year trend is going to get larger, higher. It's not going to increase. Based on the number of claims closed and the way these guys calculate their case estimates, their view probably would be optimistic that this trend of 8.7% might decrease to 6, 5, 4, whatever. Okay, let's close the number of claims close module. So you click on the X, then highlight the case reserve estimates and click on the X. And suppose we first just do a forecast continuing with this trend. So let's forecast. Okay. What kind of answer do we get? Look at the logbook. We get 593 million. You might remember that with the Mack method, we got 891. With the arithmetic average, we got 1.1 billion. So using a trend of 8%, we've got 593. How can we get the 896? Well, you could go to forecast in the dialog box. Well, before I do that, let's click on model display. Let's shift it here. Let's now click on forecast dialog box. Move it to the right. Okay, and let's be pessimistic and go to future parameters and go to change iota. And let's really assume now that this trend of 18.28% kicks in again. So one way of doing that is putting 0.18. And the standard deviation is 0.0256. Okay, I'll wait for you. Do that. So suppose it reverts to hold a higher trend of 18% plus minus 0.28. I mean, obviously, it'll be worthwhile investigating why there are major shifts in calendar year trends and the paid losses. But let's be quite conservative now. Okay, let's save this as conservative 1. Well, actually, we had scenarios in there before. Okay? But you can see it, 18% plus, I've done this before, 2.56. So why don't I save it on top of that? But you'll have to do it from the start. You'll have to call it something. Just give it a name. You could call it scenario 1, whatever you like. Save. Yes. Okay. And if you now look at the logbook, it's 751. We still can't get the A96. And to me, that's an extremely conservative scenario given what's going on in the case reserve estimates and the number of claims closed. Of course, you'll have to talk to those people to get a better idea. You do have to use some kind of judgment. But, you know, when it comes to monitoring, it'll be easier. You should try and use a conservative assumption, and then after using a conservative assumption, you should be able to monitor that assumption. And if the trend that played out was actually lower, you'll be able to release some capital as profit that we'll do in another study. Well, let's try now another scenario. What about if we bring in the 47.48, but just for 1 year? So you go to forecast. The current scenario is still there. And make it 14.78. So add another parameter, 92 to 93. 47.48. What's the standard deviation? 3.2. 0.032. Oops. Here. 0.032. I'll wait for you. So from 91 to 92, we've got 47, wow, huge trend. 92 to 2008, we've got 18.28% plus minus 2.56. Okay, let's save that. And, well, there you are. I've already saved it before, so I'll save it on top. Save that. Yes. Okay. And now you can look at the logbook. And we've got about $1 billion. That's around between what you get with the arithmetic average and the volume-weighted average. Well, this is just very, very unlikely to take place considering what's happening in the case estimates and the number of claims closed. I would probably just still make, I believe, a conservative assumption, continue with 8.7 plus 1, 9.7. Maybe, if you wanted to be a bit more conservative, you do the 8.28 for 1 year, and then the 8.71. So let's do that scenario. Forecast. Let's load the... No. Okay, I can tell you what we can do. Let's cancel. Let's estimate the model again. Click on E. Forecast now. And now create the scenario from scratch. So you're going to future periods. Change iota. Add another parameter 92 to 93. And make the first one 18.28. Well, like you could have copied and pasted 0.1828. And then reverts to 8.71%. So, okay, save that. I didn't change the standard deviation, so say 1 year, 1 year, there, reverts to default. Save. You can save it anyway. You can call whatever way you like. It's saved in the triangle group or in the database. Okay. Incidentally, if you go to Forecast Summary now, and you go to Forecast Settings tab, it should tell you what assumptions you made about the future iotas. So you know what assumptions you actually made about the future iota. And now you get an answer of 653 million. And to me, that's pretty conservative. Okay. Let's suppose we call this the scenario we're going to use. Now, if the 8% is going to continue for the next year, and thereafter, you're going to then assume, from then on, you're going to then assume that the 18.7% kicks in, and then goes back to the 8.7%. So in other words, you're going to be doing your monitoring. So I decided to make this particular study a little bit longer to include release of profit or release of capital as profit. So release profit as capital. Let me just write this down. So let's call this scenario forecast. Let's just call this scenario. Let's call this scenario or best scenario. So the best scenario. The one you're going with. Best scenario. Did I spell that correctly? No, scenario. Okay, the one you're going to go with. And do the forecast. Now we're going to run the model again. So you go to model load with the downward arrow and load model in new window. So we want another run of the same model, but we'll do a different forecast scenario. So load model in new window, M, click on the downward arrow in new window, and it's model M4 again. So we've got two runs of the same model. You go to forecast. And now, let's load the scenario we are going with, best scenario, but we go to future parameters. We're going to assume what happens, in fact, if the default, add another trend parameter, 93 to 94. The 8% actually, I'm just going to add another one, 94 to 95, so I can do some copying. Take the 18%, etc., and copy it. So highlight it, copy, and just put it there. No, sorry, put it in 92 to 93. It kicks in a year later. Oops. So it'll be just control paste. Okay, now take the 8.71%, copy, and put it in the first calendar year. Paste. So we're really saying that it's going to continue with the default trend. Then we're going to be conservative at the end of 92 and say now the 18% trend kicks in for 1 year, and thereafter it reverts to the 8.7%. Now, the difference between these two scenarios, the one that we call the best scenario and this one, will tell you how much capital you'll be able to release a profit next year if the 8.71% continued for 1 year, and at the end of 92, the conservative scenario kicks in, or the best scenario kicks in again. So let's do that. So, okay, let's save it as best scenario, release of profit, release of capital, say. Save. Okay. Now go to forecast summaries, click with the right button on both. Click with the right button and then select all. In this case it's both. And now tile vertically, minimize other types. And let's just check the forecast scenario. So you go to forecast settings on the left. And you go to future IOTAs. Okay, I mean, we had a redundant, we just had a redundant line in here. Okay, now let's compare the answers versus accident year. Sorry about that, but that was my mobile phone, so you got a little bit of Star Wars there. So there's a difference of about, what, in the millions? You're looking at about $23 million. That's the mean. You can always look at this by calendar year. So what you'll see really is that for the more conservative scenario, you're paying a lot of money in the next calendar year, $244 million, whereas in the if the default trend continues for at least another year, it's only $222 million. So that's where you're going to pay basically most of your extra money in the next calendar year, and that tells you how much capital you can release as profit. For the subsequent calendar years, you can see the distributions are the same. Okay? All right. Now, if we look at the table where we used the less conservative scenario, the forecast table, let's just look at the flow of the liability stream by calendar year. You know, the company paid $160 million, $216, $201. We're forecasting about $222. In the first development periods is about 13. So there is an increase of about that 8% or so. Okay, there's an increase of or at least 8%. Also, we overfitted the calendar year a little bit. The last calendar year must be sitting a little bit lower. Let's look at it. Can you see it's a little bit lower? If you look at the residual graph, green button here, it's a little bit lower. Go back to the forecast table. And all of a sudden, because this 18% kicks in, this becomes pretty large. Okay? All right? That's if the 18% kicks in, then it goes back to the 8%. All right? Now, of course, if the 18% didn't kick in here, all these numbers would, in fact, be lower. I mean, of course, what you could do is load a model again, go to the load, downward arrow, load model in new Windows. We're loading the model, so now we're going to have 3 runs, and just do the straight out default trend. Well, I don't know that we saved it. Did we save it? Load. No, it doesn't matter. It's just a default. So, okay. So now if you look at that forecast table, you can see that it's the 22, and the 169 is much lower than that 180, and all these subsequent numbers are lower because you don't have that huge increase of 80% that increases all future calendar years also.